Hello everyone, I'm Valeron Tan. I'm from SME to IPA B, and for today I'll be explaining to you briefly about thermophysics. Thermophysics. For this presentation, we will have 5 parts, or for the table of contents. We have heat, which includes heat, thermal energy, and temperature. Then we have calorimetry, which has calorimetry and specific heat capacity. For the third part, we have effect of heat, which has linear expansion and volume expansion. For the fourth part, we have thermal equilibrium, and for the last part, we have latent heat, which includes latent heat of fusion and latent heat of vaporization. First part, heat. We have definitions of heat. The definition of heat is the transfer of energy from one particle to another particle. Then we have definition of thermal energy. The definition of thermal energy is the energy that is generated and transferred by heat, which refers to an internal energy in the form of an average kinetic energy caused by the movement and collision of particles or molecules. And last, we have definition of temperature, which refers to the measure of thermal energy, which is the degree of hotness or coldness of a body. For thermometers, there are a lot of kinds of thermometers in this world, but it will be classified to two classifications. First, according to use, and second, according to the liquid use. For the first one, for the first classification, according to use, we have three. First is the medical thermometer. The medical thermometer is usually a thermometer that is used in clinics or hospital. For laboratory thermometer, it is usually used at labs, our laboratories. And for the last one, we have atmospheric thermometer. The atmospheric thermometer is usually used around any room to measure the temperature of the atmosphere. Then for the second one, we have according to the liquid use. For this, according to the classification, we have two kinds. The first one is the mercury thermometer, which uses mercury, and the second one, which is alcohol thermometer, which uses alcohol in it. For the units of temperature, there are 5 kinds of units. For the first one, we have the Celsius scale, or the degree Celsius. It is founded by Andreas Celsius, with freezing point of 0 degrees Celsius and the boiling point of 100 degrees Celsius. The range between the boiling point and the freezing point is 100. For the second, we have the Fahrenheit scale, or the degree Fahrenheit, a degree F. It is founded by Gabriel Daniel Fahrenheit. The freezing point of it is 32 degrees Fahrenheit and the boiling point is 212 degrees Fahrenheit. And it has a range of 180 between the boiling point and the freezing point. And the third one, we have Kelvin scale with a symbol of K. The founder is William Thomson with a freezing point of 273 Kelvin and boiling point of 373 Kelvin with a range of 100 between those two. And then we have the Reaumur scale, which is degree R, which is founded by René Antoine Verschoor de Reaumur, with the freezing point of 0 degrees R and boiling point of 80 degrees R, with a range of 80. And last, we have the Rankine scale, or R, which is founded by William John Macquarie Rankine. The freezing point of this scale is 492 R and a boiling point of 672 R, with a range of 180. For the conversion of units of temperature, we usually use the formula which is equals to the temperature minus the freezing point over the range. So if we need to convert from one temperature or another, we use the formula of temperature minus freezing point over the range equals to the temperature of the other unit minus the freezing point and over the range. For example, we have number 1, which is asked to convert 595 Rankine to degree Celsius. For the degree Celsius, the temperature is unknown, so we just put T minus the 0, which is the freezing point of Celsius, over 100, which is the range, equals to 595, which is the temperature of Rankine, minus 492, which is the freezing point, over 180, which is the range, in which we will get a temperature of 57 degrees Celsius. So it means that 595 Fahrenheit is equals to 57 degrees Celsius. For the second one, we have convert 95.5 degrees Reaumur to degree Fahrenheit. And it is using the same formula, which is for the Fahrenheit, it is unknown. So we just put T minus 32, which is the freezing point, over 180, which is the range. This is equal to 95.5, which is equal to temperature minus 0. This is the freezing point over 80. This is the range with a temperature of 247 degrees Fahrenheit. Second part, we have calorimetry. The calorimetry has two definitions. The calorimetry is the act of measuring changes in state variable of a body for purpose of deriving the heat. For the second definition, it is the process of measuring the amount of heat released or absorbed by a physical or chemical system. For the units of heat, we usually have four. The first one, we have calorie. It is the amount of heat needed to raise the temperature of 1 gram of water by 1 degree Celsius. For the second one, we have kilocalorie. It is the amount of heat needed to raise the temperature of 1 kilogram of water by 1 degree Celsius. Third, we have joule, which is the amount of heat needed to raise the temperature of 1 kilogram of water by 1 Kelvin. And the last and not least, we have the British thermal unit, or the BTU. It is the amount of heat needed to raise the temperature of 1 pound of water by 1 degree Fahrenheit. For the specific heat capacity, it is the amount of heat needed to raise or to lower the temperature of a given mass of a substance by a particular initial temperature. The specific heat of a given substance is the ratio between the rate of change of heat with respect to the given temperature and the mass of the substance. As you can see in this table, we have the specific heat capacity of 9 of this substance, which has the heat. For each these units, we have the joule over kilogram degrees Celsius, and this one is the calorie over grams degrees Celsius, as you can see. And for the conversion, we have 1 kilocalorie is equal to 1000 calories. For 1 calories, it is equals to 4184 joules. And the last one, 1 British thermal unit is equal to 1055 joules. And this is the derivation of the C equals to limit of the change in temperature, 0, change in heat over change in temperature over the mass, which becomes the heat equals to mass times the times the C equals to the change in temperature. For the third, we have the effect of heat. There are two types of effect of heat. For the first one, there is linear expansion, or the change in heat, a change in length. For the change in length, as you can see, the formula for the change in length is equals to the coefficient of linear expansion times the initial length times the change in temperature. For the second one, we have change in volume, or volume expansion. For the volume expansion, the formula is the coefficient of volume expansion times the initial volume times the change in temperature. As you can see in here, this table again, there are 11 substances, which is substances with the coefficient of expansion per degree centigrade. This will be used during the calculation of the effects of heat. For example, this question, it asks with a brick with the initial length of 0.15500 meters, with the initial temperature of 28 and the final temperature of 52, which will give us the change of temperature 24 degrees Celsius, which we'll put in this formula because we need to find the final length. The final length at the change of length is equals to the coefficient times the initial length times the change in temperature. Then we will change the formula to this, which is the final temperature, final length equals to the coefficient times the initial length times change in temperature plus the initial length. This formula, and we will get 0.15503 meters. Example question, this one is for the volume expansion. An 18 milliliter of CH3O3 LH has a temperature of 35 degrees Reaumur. To what temperature in Reaumur must it be heated so that it will be 80.5 milliliter, given that its coefficient of volume expansion is 1.19 times 10 raised to the negative 3 over degrees Celsius. Okay. And then we will use this volume, which is the final volume equals to the initial volume in brackets 1 plus the coefficient of the change in volume times the change in temperature, and then we just plug in the value of this, and we will get 49.3 degrees Celsius or 39.4 degree Reaumur. This one is example of problem solving on thermal energy. For the first one, a 4 kg of ice at negative 15 degrees Celsius started to increase temperature to negative 2 degrees Celsius. How much BTU of heat is absorbed by the ice? And then we put the given. For this one, we will need to use the formula of Q equals to M times C times the change of temperature, which is delta T. And then we will get this amount in joule, and we will convert it into BTU, which is 1055 joules and equals to 103 BTU. For the second one, we have a 140.5 kilojoule of heat is removed to a 41 kilograms of salt water, whose initial temperature is 512 Reaumur. What will be its temperature in degrees Celsius after the heat is removed? We will be given. This one is also using the same formula, which is the Q equals to MC times the change in temperature. But this time, it is asked of the temperature. For the final temperature, it will be equals to the heat over the mass times the constant plus the initial temperature, which is equal to 10 degrees for the final temperature. For the first one, we have thermal equilibrium. A thermal equilibrium happens when two media of different initial temperatures reach the same temperature after the direct contact, wherein one has a heat loss while the other one has heat gain. I'm sorry for that. And then we have two bodies, which A, we have a lower temperature while B has the higher temperature, which will make A has heat gain while B has heat loss. The formula for this is equals to the heat gain equals to the heat loss. And given for this, and then we put all the values in, and we have the final temperature for both of the substance is 23 degrees Celsius. For the last one, we have latent heat. For definition of latent heat, is the energy released or absorbed by a substance during a change of state without a change in its temperature. The latent heat of fusion is amount of thermal energy required to change a substance from solid state to liquid state without a change in its temperature. For the latent heat of vaporization, it is known as the amount of thermal energy required to change a substance from liquid state to gas state. And as you can see, there are two types of latent heat. This is the latent heat of fusion, which shows that the ice has become water without changing in its temperature, while the water turns into gas in the latent heat of vaporization. And this is where the latent fusion happens between the solid and liquid, and this happens between the gas and liquid for vaporization. And then this table shows the specific latent heat for these substances. For example, for a question, we have 5 kg acetic acid at 5 degrees Celsius is exposed to heat until reaching a temperature of 20 degrees Celsius. How much total BTU of energy would be required in order to reach that temperature? We put it given from this problem here. And then for this, we need to draw the graph from 5 degrees Celsius. And because for acetic acid, I'll go back. For acetic acid, the latent heat for it is at 17 degrees Celsius. So from 5 to 17, there will be one stage of heat gathering. Then this one will be the latent heat, and this will be the last stage. Then for Q1, for the Q, the formula is Q equals to mc times the change in temperature. And you plug in the number. For the latent heat, it is equals to, the formula for it is the mass times the constant for each of the substance. For the second one, it's still the same as the first formula. And then we can get it in joule and convert, and we can get 1065 BTU. This one is also the same problem as the one before. And that's it for my presentation today. Thank you very much.